Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shown is HCCCH2CH is equal to CH2. It contains a terminal triple bond, alkyne, and a terminal double bond, alkene, within a 5-carbon chain. Moving on to the next step. C1C2C3C4 is equal to C5. There are 5 carbons in the longest chain containing both unsaturations, so the parent chain is pent. Moving on to the next step. Number the chain to give lowest locants to the principal characteristic group and multiple bonds. IUPAC rules prioritize giving the lowest possible locants. Numbering from the alkene end, C1 is equal to C2, C3, C4, C5 would give double bond at 1, triple bond at 4. Numbering from the alkyne end, C1, C2, C3, C4 is equal to C5 would give triple bond at 1, double bond at 4. When an anion is named, the double bond, Na, gets the lower locant according to IUPAC 2013 recommendations when the set of locants is the same by either direction. Here, 1, 4 versus 1, 4 are the same set, so the double bond, Na suffix, gets the lower number. Therefore, numbering starts from the alkene end, double bond at C1, triple bond at C4. And for the final step, parent chain is equal to pent, double bond at position 1 is equal to pent-1-en, triple bond at position 4 is equal to pent-1-en-4-yne. Pent-1-en-4-yne corresponds to CH2 is equal to CH, CH2, CCH, which matches the drawn structure HCCCH2CH is equal to CH to read from either end. Therefore, the correct answer is pent-1-en-4-yne. The correct answer is shown on screen.